For 1a, we need a least common denominator to add these fractions. And if I examine both denominators, the factors are completely different. And this means it's going to be the product of the two denominators. So when I set up adding these two fractions together, I have to ask myself, for the first fraction, what am I multiplying by to get my least common denominator? And that would be x minus 3. For the second fraction, to end up with my least common denominator, I'd have to multiply by x plus 2. I'll include some parentheses, just so we're careful that we're multiplying these expressions together. And let's see what we get. I'll put the x plus 2 up here. I now have a least common denominator. It is x plus 2 times x minus 3, and I'll leave it as that. For these two, since it's 1 times x minus 3, I'll just put x minus 3 here, copy down the plus sign, and then I'll have 1 times x plus 2. So that is, I have x minus 3 plus x plus 2. If I combine like terms, I get 2 x's, I get a negative 1. This is all divided by x plus 2 times x minus 3, and that is my final answer. Okay, same idea for the second problem here, 1b. I need a least common denominator. And again, both the denominators are completely different. So it's going to be x times x minus 5. Same process. For the first fraction, I need to multiply by x. And for the second fraction, I need to multiply by x minus 5. In doing so, I now have a least common denominator of x times x minus 5. My numerator is going to be 2 times x, which is 2x, plus 3 times x minus 5. I have to be careful here to distribute the 3 to both terms. This gives me 2x plus 3x minus 15 all over x times x minus 5. And if I combine like terms, I get 5x minus 15 all over x times x minus 5, and that is it. For 1c, same idea. I see that both x plus 3 and x plus 1 have no factors in common, meaning this is my least common denominator. So I will simply take my two fractions and multiply in what is missing. For the first one, it's the x plus 1. And then for the second one, it's the x plus 3. Since I now have a least common denominator, I'm going to write that as x plus 1 times x plus 3. I won't multiply it out. But for the numerators, I'm going to have x times x plus 1, so I'll be careful to write that with parentheses. Then it's going to be plus, okay, 1 times x plus 3, this times that. It simply means I can put x plus 3 here with no parentheses, so I'll just put x plus 3. We are practically done. We'll just distribute the x. That gives me x squared plus x plus 3 all over x plus 1 times x plus 3. And if I combine like terms, there's not too much to do there. There's 2 x's. And this is my final answer. Same idea for part D. I see the least common denominator is simply going to be x plus 2 times x minus 3 because there's nothing in common. I think the only thing that's really happening for these first 4 problems is that the numerators are a little bit more complicated, but the idea is in fact the same. So what I will do is take the first fraction. I'm going to put parentheses around the factors, but then multiply in what is missing, which is the x minus 3. I then have x over x minus 3, and I'm going to multiply in the x plus 2. So this means I have a least common denominator of x plus 2 times x minus 3. For the piece that goes here, it's going to be the product of those two, so I'm just going to write that down as x plus 1 times x minus 3, then plus the product of these two things, which is x times x plus 2. All right, I'll have to FOIL this. Over here I can simply distribute in the 2, so I'll just mark that like this. So I have to be careful with the first two factors. I have my common denominator, but maybe off to the side I'll note that, okay, really we're multiplying x plus 1 times x minus 3. And if I FOIL, I first have to distribute the x, so I get x squared minus 3x. But then I also have to multiply in the 1, which gives me x minus 3. And if I combine like terms, I get x squared minus 2x minus 3. That's the product of these two things. I'm going to write that right here. That was x squared minus 2x minus 3, plus, if I distribute the x, I get x squared plus 2x. So altogether, my final answer is there were 2x squareds. There are no x's. We have a negative 2x and a positive 2x, so those cancel, and we're left with minus 3. I have my least common denominator of x plus 2 times x minus 3, and that is the final simplified answer. All right, so for this next problem, I see that the fraction, the denominator of the first one, is not factored. So I'm going to factor it. If I take out an x, I get x times x minus 1. And I'm adding that to 4 over x. The reason that I'm doing that is because the least common denominator is going to be, well, if I look here, I know I need a factor of an x, but I only need one of them. And there's an x minus 1 here, which means I have to include that as well. And this is going to be the least common denominator. This means for my first fraction, I don't need to do anything. I already have the least common denominator. I can multiply it by 1, but I'm just not going to write that. For the next fraction, okay, I see I am missing the x minus 1, so I will multiply that in. My next step is, well, I have my least common denominator of x times x minus 1. I didn't change the first fraction, so I simply just copy down this 2 and the plus sign. But next, I need to multiply the 4 times the x minus 1. To complete this problem, I'll distribute the 4. So I have 2 plus 4x minus 4 all over x times x minus 1. After combining like terms, we have 4x minus 2 all over x times x minus 1. And that's it for this one. All right, same idea for the one part f here. I see that the first fraction is not factored. I'm going to try to factor it. It's x over, okay, if I'm going to break this into hopefully two pieces, it's got to be an x and an x. There has to be a positive and a negative. Two numbers that multiply to negative 8, yet add to positive 2 are going to be 4 and 2. And the reason is the product is negative 8, and then the sum is positive 2. So now, I think we can figure out what the least common denominator is equal to. I see that over here I have an x plus 4 and an x plus 4, so okay, we have to include an x plus 4. I need that. There's an x minus 2 here, and there is one here, but the fact that there is one means you have to include one. and this is going to be the least common denominator for the two fractions. For that first fraction, it simply means I'm not going to do anything to it. It's already set up perfectly. But the second fraction is missing something. It is missing the x minus 2. I now have a least common denominator, the x plus 4 times x minus 2, and my numerator is going to be x plus, and then the product of these two things. So that was x plus 3 times x minus 2. I have to carefully distribute in the 3. So I get x plus 3x minus 6. Okay, the denominator of x plus 4 times x minus 2. I think we're practically there. That's 4x minus 6 all over x plus 4 times x minus 2. And this is my final answer. The process is no different if we're subtracting instead of adding. In either case, you still need a least common denominator. And I see for these two fractions that it has to be x plus 1 and x minus 7, since both of those are completely different. Therefore, I'm going to take my first fraction and I'm going to multiply it by x minus 7. And for the second fraction, sorry, I made a mistake there. That should be minus, since we're subtracting instead of adding. But for the next fraction, I have x minus 7. I don't have the x plus 1, so I'll multiply in x plus 1. The only difference in this process is after we have our least common denominator of x plus 1 times x minus 7, I have 10 times x minus 7, which I'll write down first. But I'm now going to copy down the minus sign. I'm subtracting these two instead of adding them. And for the next piece, it's 5 times x plus 1. I'll distribute the 10, as well as that's really a negative 5 that's being distributed. That's 10x minus 70. We get minus 5x minus 5. If I combine like terms, that's 5x, negative 70 minus 5 more is negative 75. And this is my final answer. Okay, so for B, I need a least common denominator, but I'm thinking that I can factor that first fraction. Let's see. I'm hoping it breaks into two pieces. It has to be an x and an x, a positive and a negative. So it's going to be positive 4 and negative 1. And the reason is the product is negative 4 and the sum is positive 3. This means the least common denominator has got to be, I need x plus 4, but also x minus 1. So let's set this up. I don't have to do a thing to my first fraction. Maybe I'll just include some parentheses around the x plus 2. But with my second fraction, I need to include multiplying it by x minus 1. So let's see what happens. Okay, I have a least common denominator. That's x plus 4 times x minus 1. The numerator on this fraction is x plus 2, not being multiplied by anything, so I'm just going to copy it down here as x plus 2. Then it's going to be minus. All right, I have to be careful here. It is 1 times x minus 1, which means you do write x minus 1 here, but the fact that we're subtracting means I'm also going to include some parentheses. That is really important because there's technically a negative 1 here that gets multiplied into both terms, so we have to be careful. This is x plus 2 minus x plus 1 all over x plus 4 times x minus 1. It turns out that all the x's in the numerator cancel, and we're left with 2 plus 1, which is 3, all divided by x plus 4 times x minus 1. And this is my final answer. All right, for question 3, thinking ahead about solving equations, not just adding or subtracting rational expressions, the goal is for 3a, find the number that makes this equation true. I bet you could even guess the answer. It's not too complicated of an equation. But there's a procedure that works out really well for solving something like this. You would still start by figuring out what the least common denominator is equal to, and since the other denominators are 1, I can see the least common denominator is x. So our approach is going to be to multiply both sides of this equation by x. Let's do that and see what happens. If I multiply this side by x, I'll just place an x over 1 in front of these two fractions. So that is, I'm multiplying both sides by x over 1, and that gets multiplied to the first thing, which is 1 over x. And then again, I multiply that x over 1 to the 5 over 1. I just multiplied the left side by x, or technically x over 1. I have to do the same thing to the right side, so I'm multiplying x over 1 to 4 over 1. Why does this help in terms of solving an equation like this? And the reason is I cancel those x's, it's now just 1's in place. Every other denominator is in fact 1. It means you removed the fractions from the problem. So let's see what's left over. That first product is just 1. The second is x times 5, or 5x. And on the other side, we have 4x. So even more than just getting rid of the fractions, it changed this into a very simple linear equation. So to solve this, I'm going to, I guess I'll subtract 4x from both sides. That gives me 1 plus x is equal to, well, 4x minus 4x is 0. I'll then subtract 1 from both sides, and I get x is equal to negative 1. I can see this is definitely the answer to the original equation, because if you put negative 1 here, this is now equal to negative 1. And then if you add that to 5, it certainly takes you to 4. So that's the approach. Multiply both sides by the least common denominator. It will get rid of every single fraction. So let's check that out in part B. Okay, so for this equation, to figure out the least common denominator, I want to make sure I factor each of the denominators. And the first two are already set up for us. But the last fraction, I can take an x out from both terms. And after doing this, it makes it a little bit easier to see that the least common denominator must be x times x plus 2. What I'm going to do is take this and multiply it to each fraction. So I'm multiplying x times x plus 2 to both sides of this equation. Let's try it out. So that's x times x plus 2 over 1. I am multiplying that to 4 over x plus 2. I then do the same thing, multiply x times x plus 2 to 2 over x. And the last step is to do the same thing on the other side. Multiply x times x plus 2 to 1 over x times x plus 2. It's kind of a mess, but what it does for us is the following. I can cancel the x plus 2's, and that reduces this to just 4 times x, and the denominator is 1, so I'm not going to write it. For the next piece, I can cancel the x's, and that means I'm left with 2 times x plus 2, and on the other side of my equation, it's even better. I can cancel the x with the x plus 2 with the x plus 2, and the only thing that's left over is 1. So this is quite a lengthy step, but it takes this confusing equation down to a much simpler one. I'll distribute the 2 and solve it for x. Let's see what we get. I get 4x plus 2x plus 4 is equal to 1. If I combine like terms on the left, I get 4 and 6x. I guess I'll subtract 4 from both sides, and that gives me 6x is equal to negative 3. And after dividing both sides by 6, this takes me to my answer. X is equal to negative, well, 3 over 6 is the same thing as a half. You could write a decimal, but this is the solution to the equation.